Namaste student. Today we are going to see a third part of a limits and continuity. Okay. At the end of the session, students, you will be able to examine the various concepts of continuity and evaluate the continuity of algebraic function. Yes. What is continuity? Yeah. A graph has no jump. We call it as a continuity. And here I am going to show you four types of graph to make you understand what is continuity. First graph. In this first graph, you may see that the left hand curve comes over here and the right hand curve comes over here. And there is a ring between this left hand and right hand curve. That shows that if the ring is not there, then there won't be a continuity. Limit x tends to a power minus 1 f of x means left hand limit is not equal to limit x tends to a power plus f of x. That means right hand limit. They are not equal. This it shows in the first graph. And second one, you may see the left hand curve comes over here and the right hand curve comes over here, and there is a jump between these two graphs. It shows that it is not a continuity. Okay. Yes. Now the third one. In the third one, the left hand graph goes upward and the right hand graph goes upward. That means they will meet at infinity. Even though they meet at infinity, the graph is not contiguous. That means limit x tends to a power minus 1 f of x is equal to limit x tends to a power plus f of x tends to what? Infinity, because the left hand limit and the right hand limit meet at the infinity. Okay. Yes. And the last graph is here. You may see the graph, the left hand limit and the right hand limit meet at a one point, call it as x is equal to a. So it shows that limit x tends to a power minus f of x is equal to limit x tends to a power plus f of x is equal to f of a. F of a is nothing but what? It's a y value where that x is equal to a. They are all equal. Then you can say the curve is continuous curve. Okay. Yes. What is continuous at a point? A function f of x is continuous at x is equal to a. Limit x tends to a power minus f of x is equal to limit x tends to a power plus f of x is equal to f of a. If you prove this, all these values are equal, then you can say the graph is continuous. Okay. Yes. Now we'll move on to examples. In this topic, the questions were asked in three types. A type 1 is when function has the same definition. That means same function on both the side of the given point. That means what they are trying to say, here it is x-axis and y-axis, a graph is going like this. Okay. Now we want to find whether the graph is continuous at this point or not. And the function is given it as what is here? Modulus x by x. That means here this left hand side. Which one is left hand side here? This one is the left hand side. Here the function is modulus x by x. And the right hand side of this limit is this side. Right? So here also the function is same. That is modulus x by x. That is type 1. The function on both the side, in both left hand side as well as in the right hand side, has the same function, means it comes under type 1. That means they will give the equation in this way. Here they given x is not equal to 0. That means we have to consider that x is less than 0 means this is the function, and x is greater than 0 means this is the function, that is modulus x by x. And if x is less than 0 means what it shows, that is x is less than 0 means left hand limit, x is greater than 0 means right hand limit. Okay, in this type 1 both the side has a same equation. Now we are going to check whether this function is continuous at both the left hand side as well as in the right hand side. For finding this one is continuous or not, what we have to find, we have to check that limit x tends to a power minus f of x is equal to limit x tends to a power plus f of x is equal to f of a. That means this is nothing but what? This one is left hand limit value and this one is the right hand limit value, and this is a value at that point. Or if all these three are equal, then you can say the function is a continuous function. Now I am going to prove this one. For that, first I am taking the function. Here the function f of x is given it as modulus x by x. Modulus means the value of x is negative, that is you will get minus x value, that is minus x by x, when the value is, that is x is less than 0, that is the negative value of x, and plus x, that is x. Modulus means both positive and negatives are there, right? So I am splitting this. So x by x means x is greater than 0. The first step is we need to split this modulus of x by x for the lower limit, that is left hand limit, as well as for the right hand limit. Here I am going to split directly, that is I can write minus x by x, and at that point x is what? Less than 0. And then x by x when x is greater than 0, and for x is equal to 0 they itself given it as 1. So x is equal to 0, the function is what? 1. Okay, now I am going to substitute the limit for that. So limit x tends to 0 minus f of x. What is f of x here? Here, before substituting the value, here I am having minus x by x, right? So this x and this x will get cancelled, you will get 1. That is minus 1 for left hand limit. And for right hand limit, limit x tends to 0 plus f of x is equal to, for right hand side what is the function? X by x. So you will get x by x, and this x and this x will get cancelled, you will get 1. Now a left hand limit is what? Here left hand limit value is minus 1 and right hand limit value is plus 1. Therefore it shows that the function is discontinuous. You have to write the function as a discontinuous. Therefore f of x is discontinuous because they are not equal, right? So you have to write it discontinuous. Okay, at x is equal to 0. Okay, now you understand how to solve the question? Fine. Next example 2. Here they given e power 1 by x minus 1 whole divided by e power 1 by x plus 1, and here they given x is not equal to 0 and they given x is equal to 0. That means here also we are having a same function for the left hand side as well as for the right hand side. That is, x is less than 0 and then x is greater than 0. We have the same function this. Okay, fine. Now here we are having e power 1 by x. If I'm replacing that x is equal to 0, here I can't able to replace it. That is, only one 0 value is there, right? We are not having minus 0 and plus 0, right? Only one 0 is there. We can't put sign for 0, right? So what I'm trying to do now, I'm going to take x is equal to 0 minus h. This is for left hand side. So I can take x is equal to what? Minus h. And for right hand side, I'm going to take x is equal to 0 plus h. That means x is equal to h. And this I'm going to take it for a left hand limit, and this I'm going to take it for right hand limit. Okay, now shall we change this one? Yes, limit x tends to 0. Instead of x tends to 0 minus 1, I'm going to take h because I'm changing the limits. That is, x I'm going to change it as an h. So I want to change the value also. So h tends to 0 e power, what I have to write? 1 by, instead of x, I want to write it as minus h because this is for a left hand limit. So minus h minus 1 whole divided by e power 1 by minus h plus 1. Okay, yes. Now next, here we are having a negative power. So I'm going to bring it to the denominator to make it as a positive. So what will happen? Limit h tends to 0 1 by e power 1 by h minus 1 whole divided by 1 by e power 1 by h plus 1. And what is the next step I'm going to do now? I'm going to tell you one formula. That is, when limit h tends to 0, e power, that is 1 by e power 1 by h means your value is 0. So here I'm having e power h. So I'm going to split the limit separately for the numerator as well as for the denominator, and then I'm going to replace this one. Okay, first I'm going to split the limit separately. So limit h tends to 0 1 by e power 1 by h minus 1 whole divided by limit h tends to 0 1 by e power 1 by h plus 1. Now if I'm placing the value over here, it will become 0 and 0 minus 1. So 0 minus 1 divided by 0 plus 1. Then you will get the answer as what? Minus 1. So left hand limit value is minus 1. Okay, now I'm going to take the RHL. Okay, for that I will write it here. Left hand limit value. Left hand limit value is what? Minus 1. And now I'm going to replace the value of x as a h because I'm going to take what? Right hand limit. So limit h tends to 0, it will become e power 1 by h minus 1 by e power 1 by h plus 1. And I need 1 by e power 1h, right? So I'm going to take this e power 1 by h as a common. So what will happen? Limit h tends to 0 e power 1 by h, and then I will get 1 minus 1 by e power 1 by h, and in the denominator also the same, e power 1 by h, and it will become 1 plus 1 by e power 1 by h, and this e power 1 by h and this will get cancelled. In the next step, I am going to split the limit for the numerator as well as for the denominator. So limit h tends to 0, 1 minus 1 by e power 1h by limit h tends to 0, 1 plus 1 by e power 1 by h. While I am substituting, it will be what? It will become a 0, right? So 1 minus 0 by 1 plus 0. Then you will get the answer as 1. Already we found left hand limit value is minus 1, and we got RHL, that is right hand limit value is 1. It shows that they are not equal. That is left hand limit is not equal to right hand limit. Therefore, f of x is a discontinuous. Okay, fine. Example 3, it is also a type 1. Here also they given x is not equal to 0. So we have to take x is less than 0, that is left hand limit, as well as x is greater than 0 means right hand limit, and same function for the left hand limit as well as for the right hand limit. Okay, fine. And now here I am having e power x minus 1. So we know the formula for this, that is limit h tends to 0, e power h minus 1 by h is equal to what? 1. Limit, another formula, limit h tends to 0, log of 1 plus h by h is equal to what? 1. Please don't forget this formula, because we are going to use again and again in this chapter. Okay, fine. Now I am going to take the left hand limit, that is LHL. LHL is what? Here the left hand limit is what? This one. So limit h tends to, again I am going to take the same, that is x is nothing but what? 0 minus h, because left hand limit. Then x is equal to minus h. And for the right hand side, x is equal to 0 plus h. That means x is equal to h. So limit h tends to 0, e power what? Minus h minus 1 whole divided by log of 1 plus 2 of minus h. This 2 of minus h has become what? Minus 2h. Minus 2h. Okay, fine. Now, if I am going to use this, I am having e power h minus 1. By h is there, but here I am not having a denominator h. And for this formula also I am having a h over here. Fine. So I am going to divide by 1 by h for both the thing, for both numerator as well as for the denominator, and simultaneously I am going to split the power also. Sorry, limit. So limit h tends to 0, e power minus h minus 1 by minus h, and then limit for the denominator h tends to 0, log of 1 minus 2h by minus h. And for the numerator, there is no problem. Here I am having minus h, and here also minus h. But here I am having minus 2h. But here I'm having only minus h. So I need what? 2. Here I'm going to write 2. So what will happen? I want to multiply and divide by 2. That's the thing I did. And what will happen here? H tends to 0 means minus h also tends to 0. And here minus 2h is also tends to 0. Now the value of this become what? Value of this become 1 and value of this become 1. So 1 by 1 into 1 is 2. This is LHL. The LHL value is what? 1 by 2. Simultaneously, I am going to do for the RHL. So RHL. Here I want to take x is equal to what? H. So limit h tends to 0 e power h minus 1 divided by log of 1 minus what? 1 minus or plus? Plus 2h. Okay. Now I am going to divide both the numerator and denominator by h, 1 by h, and then I am going to split the limit also. So limit h tends to 0 e power h minus 1 by h whole divided by limit h tends to 0 log of 1 plus 2h by h. But I need water. In the numerator there is no problem. But in the denominator here I am having 2h. Here also I need 2, right? So I am going to multiply and divide by 2. If h tends to 0, 2h is also tends to 0. Now what will happen to this? It will become 1 and this will become 1. So 1 by 1 into 2. 1 into 2 is what? 2. RHL value is what? RHL value is 1 by 2. Therefore, I can say it is contiguous? No. I had checked only the left hand limit and right hand limit. What will happen to f of that exact value? X is equal to 0. What is the f of 0? F of 0 is given it as 7. Therefore, it is not a contiguous. That f of x function is not a is a discontiguous function. Okay, if it is contiguous, all the three should be equal. Left hand limit, right hand limit, and that function value at that point also be equal. So it is not contiguous.